Alright, so for today's lesson we are going to be looking at the notes for limiting reagents, so go ahead and make sure you take those out. And lucky for you, today you don't have to do a summary or essential questions. So don't worry about doing those, you won't have them. I just want you to focus on completing these worksheets today. Now, before we get started on these notes, I just want to give you a little analogy that I want you to make sure you're paying attention to. Let's say that we work in a bicycle factory, and just a little side job we have 6 tires, 6 bicycle tires. But we have all the other parts except we only have 2 bicycle seats. Now, discuss with your partner how many bicycles can we make. I'm going to give you just about 20 seconds, let you discuss with your partner, and then I'll come back. Alright, if we consider just the tires, we know that every bicycle, well, at least a standard bicycle, has 2 tires. So each set of tires can make 1 bicycle. So we have 1 set of tires here, we have another set of tires here, another set here. So with just our tires, we have the potential to make 3 bicycles. Now, every bicycle has 1 seat, so if we have 2 seats, we are limited to 2 bicycles. Now, from this information, we get 2 important things. First, the bicycle seats are the limiting, because they limit how many bicycles we can make. We cannot make 3 bicycles even though we have the tires to do so. We can only make 2 bicycles because the bicycle seats are limiting how many we can make. So that means we would make our bicycles and we would have 2 tires left over. So the bicycle seats are what we call in chemistry the limiting reagent or reactant. And then the bicycle tires are what we say we have excess amounts. Sometimes you'll also see this as unlimited, but usually this is referred to as the excess material. Now, going back to these notes, we're going to look at limiting reagents in terms of chemical reactions. So as it says up here, in a chemical reaction, the one that has the insufficient quantity will limit the amount of product that can form. So meaning that if we have one that is limiting, we are limited in how much product is actually made, because we simply don't have enough of those materials to make it, just like we didn't have enough bicycle seats to make enough bicycles, even though we had extra bicycle tires. Alright, so for this problem, we're going to solve what it says here. So it says copper combines with sulfur to form copper 1 sulfide. So here's our balanced chemical equation right here, and then here's our question. Again, we circle what it's asking for, so it's asking for grams of copper sulfide, but this is where it gets a little bit confusing. We now have 2 possible amounts to use, whereas before when we did these problems we only had 1. So we have 2 possible amounts to do, so this is actually like 2 problems in 1. Alright, so to solve this problem, we need to go through 3 steps. Step 1, we are converting all reactant quantities to grams of the desired product. So in this case, it gives us grams of our reactants, but sometimes it might give us moles. So what we need to do is also use our stoichiometry roadmap when we do this, so we know what we're starting with and where we're going. In this case, it's giving us grams, so we have 2 sets of grams to use. So we're going to start with just using copper. Now, before we solve this, because I'm a nice teacher, I'm going to give you the molar masses of these. So from here we know that copper, from the periodic table, copper has a molar mass of 64 grams per mole. Sulfur equals 32 grams per mole. and copper 2 sulfide, so Cu2S, equals 160 grams per mole. Now, step 1 says to convert all the reactants to the desired product. So the first reactant we're going to use, like I said earlier, is copper. So we are starting with 80 grams of copper, and we are wanting to convert it into grams of Cu2S. Using our stoichiometry roadmap that we've been doing last class and earlier this class, we know that going from grams of copper into grams of another chemical is a 3-step stoichiometry problem. So we set up our 3 steps, and now we solve. So I'm going to go ahead and let the sub pause the video for a minute or two while you solve this problem, and then I'll let you double check it with my answer. Okay, by now you should be done, so I'm going to go ahead and show you the answer. Alright, so our answer here is 100 grams of copper sulfide. So again, this right here, we get this from molar mass. Again, this all comes from the stoichiometry roadmap we've been using. This comes from our mole ratio and the coefficients, and this one again comes from the molar mass from the periodic table. So by now, I'm hoping that you're starting to understand how we're getting these. So we just did half the problem. The next half the problem is we need to do the same exact thing, but instead we're going to start with 25 grams of sulfur. Sulfur, so that's 25 grams. That's an S, not a 5. And we're still converting it to grams of copper 2 sulfide. The only thing that's changing right now is our starting number. So we have 25 grams of sulfur. We set it up. We're going from grams of one chemical to grams of another. So by now you should be familiar with your roadmap. That means it's a 3-step problem. So we write down our steps, and now we can fill it in. I'll go ahead and fill this in with you. The first one, remember, is molar mass. So we take 1 mole of sulfur is equal to 32 grams of sulfur. We have 1 mole of copper 2 sulfide is equal to 1 mole of sulfur. So it's a 1-to-1 ratio on the mole ratio. So what we've done at this point is during the first step we successfully got rid of grams of sulfur and converted it to moles of sulfur. But our answer is not in sulfur, it's in copper 2 sulfide. So we now have to get rid of sulfur. So moles of sulfur have canceled off. So now we're left with moles of copper 2 sulfide, but we want grams of copper 2 sulfide. So again, using molar roadmap, we proceed with the problem, and we get 1 mole of sulfur is equal to 1 mole of copper 2 sulfide is equal to 160 grams of copper 2 sulfide. Now at this point, the moles of copper 2 sulfide have canceled off, and we are now left with grams of copper 2 sulfide, which is exactly what we want. So now we can do the math behind this. So we have 25, multiply it by 160, and then the product of those two numbers divided by 32. That gives us 125 grams. So our final answer is 125 grams of copper 2 sulfide. Now we have these two amounts. We've found that 80 grams of copper can produce 100 grams of copper 2 sulfide. We found that 25 grams of sulfur can produce 125 grams of copper 2 sulfide. So now, based on this information, I want you and your partner to take 30 seconds, see if you can figure out which one of these, copper or sulfur, is the limiting reagent and which one of these is the excess reagent. So I'm going to give you 30 seconds and then we're going to come back here and do this. Alright, so step 2 for these problems says identify the reactant that yields a smaller amount of product. So what we need to do is compare 100 grams of copper 2 sulfide to 125 grams of copper 2 sulfide. Now I know this is pretty straightforward, but let's go ahead and just compare them quickly. So we set up a little inequality. We have 100 grams and compared to 125 grams. So now we have 100 grams compared to 125. Obviously 100 is less than 125. So because copper can only produce 100 grams of copper 2 sulfide, whereas the sulfur could produce 125 grams of copper 2 sulfide, that means that copper is in fact the limiting reagent. So I'll just write that over here and I'll let you write it as well. So copper equals limiting, and then the sulfur is in excess, meaning we have extra sulfur left over. After this reaction happens, we are going to have extra sulfur because not all of the sulfur got used up, only enough to react with all the copper. The copper got used up first, so once the copper was used up, there is no more copper to react, and so the sulfur just stays where it is. And that is the fundamental of limiting reagents. So now for step 3, we're going to come up with a final statement that summarizes everything we've just established. Okay, so using this information, here's a statement I came up with. Reacting 80 grams, so I'll say it first and then I'll write it down so you can copy it. Reacting 80 grams of copper with 25 grams of sulfur only produces 100 grams of copper 2 sulfide. So go ahead and write that down. So again, because copper was limiting, meaning we only had a limited amount of it, we had excess sulfur, when we reacted 80 grams of copper with 25 grams of sulfur, it only produced 100 grams of copper, copper 2 sulfate, even though we had enough sulfur to make 125 grams. We couldn't make 125 grams because we ran out of copper before we got to that point. So now what I'm going to have you do is for about 10 minutes, you guys go ahead and work with your partner on finishing, on doing some of these problems in the notes. After 10 minutes, then I want you guys to have some time to work quietly on your own. Once you're finished with the notes, then you can move on to the classwork and start working on those problems. Now, if you do have questions, remember, go ahead and put any questions on Edmodo tonight, and I will get back to you as soon as I can. Also, I will leave a key with the sub, so just like always, the key will be up front. You can go check it for answers, see if you've gotten them correct, see how you're doing, see if you've made any mistakes, whatever you want to do. Just make sure you aren't copying or you're not writing anything down. But good luck on this, and I will see you guys next time.